All right, we are back. We are in section 7.5, looking at complex numbers. What are complex numbers? Good question. Let's go to the notes and find out. Complex numbers, they're actually a combination of a couple different things. So first and foremost, up to this point, we've been looking at real numbers. Complex numbers are made up of real numbers and, this is going to sound kind of crazy, but imaginary numbers. Yes, there are such things as imaginary numbers. You're probably thinking to yourself, did people just sit down back in the day and think up, like, what are the craziest things that we can come up with? Like, what the heck is an imaginary number? It's a great question. So, let's go ahead and take a look. When we're dealing with radicals, okay, there are problems that we encounter. Specifically, for example, how to find, think about it, the square root of minus 4. Can you do it? It's really not possible, I guess, if you think about it. The reason why is because 2 times 2 is equal to 4, but if you did minus 2 times minus 2, you get positive 4 again. So that's a problem. There's no two numbers that when multiplied together that are the same, that when multiplied together will give you a minus 4. But there is. This is where the idea of an imaginary number comes in. So we call the imaginary unit I. Okay, it's a little italicized I, and it's a number so that you have I squared is equal to a minus 1. Now the implication from that is that I, when you take the square root, I is equal to the square root of minus 1. Okay? So, an imaginary number, this is saying that if a is a positive real number, then if I have the square root of minus a, that means that this is the same thing as I times the square root of a. So, for example, let's take a look at square root of minus 27. This is the same as I times the square root of 27, which is the same as 3 times I times the square root of 3. 3 times 3 is 9, 9 times 3 is 27. That's why I can pull that 3 out. Okay, so this is the fully simplified form of this. Okay. Again, don't worry, we're going to do a ton of examples, so hopefully this makes a whole lot of sense. Now, this is an imaginary number, but a complex number is made up of real and imaginary numbers. Okay, so an imaginary number has an I in it, a real number is just a number. Complex numbers are a combination of the two. So a complex number is of the form a plus bi. A is called the real part. Bi is the imaginary part. So this is what's called a complex number. The standard form is written as a plus bi. There's no fractions. There's no, there's no higher powers raised of each of these. It's just a plus bi. Okay, you can't have any higher powers of I in standard form. And we'll talk about that here in a minute. Adding and subtracting is just like if you treat I like another variable. It's very, very similar. So you can add the real parts together and you can add the imaginary parts. And same with subtraction. You can't cross over, so you can't combine real parts and imaginary parts. You have to combine real with real and imaginary with imaginary. So in other words, if I've got this guy right here, 3 minus 4i minus 2i, let's distribute that minus sign, combine the 3 and the minus 2 to get a positive 1, the minus 4i and the positive 2i to get a minus 2i. Okay. Multiplication and division. I'm going to go through some examples here, so hopefully you can see that. Complex conjugates, we'll talk about this. I may have secretly, accidentally mentioned it a couple of lessons ago. But yeah, I'll fully explain what this specifically refers to when we work on these problems. Okay, now to the fun part, going to the whiteboard. So let's take a look at some questions. Question number 14. Some of these are just, we're going to simplify, okay? So I have the square root of minus 64, and they're asking us to find the solution, or fully simplified form, okay? So this is the same as the square root of minus 1 times 64, which is equal to the square root of minus 1 times the square root of 64, which is equal to 8 times I. Okay? This right here is I. This right here is 8. So those two things are multiplying together. That's a 6, by the way. Those two things are multiplying together, so that's where we get the 8i from. Okay? 18 minus 5 times the square root of minus 81. Okay? This is the same thing as minus 5 times the square root of minus 1 times the square root of 81. Okay? Square root of 81 is 9. 9 times 5 is going to be this is a minus 5, minus 45. And the square root of minus 1 is I. Okay? So yeah, anytime you see something like this, so this is a little bit of tactical advice when you approach these problems. We're going to be factoring, just like we were previously the last couple sessions, to try to find the perfect squares. In this case, in both these problems, it worked out where 81 is a perfect square, so it makes our life a lot easier. But the next question is not that case. So here, this is asking us to find the square root of negative 72. Okay. Now, if you remember your perfect squares, which I hope you do, you'll notice that this 72 is the same as 36 times 2, and 36 is a perfect square. So this is the same as the square root of minus 1 times square root of 36 times the square root of 2. And this is going to equal 6 times square root minus 1 times square root minus 2. Whoop, positive 2, sorry. Positive 2. So this is I, this is 6. So we get 6 times I times square root 2. And that's our final answer. All right, let's go ahead and now we need to put these in standard form. So question 28, minus 6 minus square root of negative 25. Okay. This is the same as minus 6 minus square root minus 1 square root 25, which is equal to minus 6 minus a square root of 25 is 5. And this is I. 5i. Okay. A lot of times these minus signs, especially underneath the square root, will throw you off. So I hope it doesn't, but just keep in mind that this is what the final answer is going to be. Okay. All right, let's go ahead and do one a little bit trickier. Honestly, I love complex numbers because they're kind of weird, to be honest with you, but they actually, surprisingly, there are real world applications for it. In electrical engineering, imaginary numbers actually show up quite a bit, which is really, really surprising. Because you do have like a very real world example or real world kind of application for these things that are supposedly imaginary, right? Plus, it's just kind of cool. If you actually look at the history of it, history of math is really interesting in how everything came about. But they actually had a concept or idea of imaginary numbers prior to the idea of 0. Think about that for a second. The idea of 0 came after the idea of imaginary numbers. So, how about that? Little factoid for you. All right. So here we have this problem. This is going to be minus 6 minus 5 times square root minus 1 times square root of 4 all over 8. Okay. And now let's do just a piece at a time. So that's going to be 2. That's going to be I. And we have minus 5. So minus 5 times 2 times I is going to be this. Minus 6 minus 10 times I. And then we get that. So minus 6 over 8 minus 10 over 8 times I. And when you write these out, sometimes you'll get fractions. So this is the real part right here. This is the imaginary part over here. You write the whole thing out as a fraction and then put the I at the very end. So kind of like multiplying times whatever that fraction, that fractional coefficient. So this will be minus 3 over 4 minus, this will be 5 over 4. I'm just simplifying these. Okay, so there we go. Perfecto. All right, now let's do some adding and subtracting. Like I said, I mean, it's very similar to if you had a variable. If you had like an x, it's pretty much identical. So minus 2 minus 4i minus 6 minus 8i. Okay, this is equal to. First off, let's distribute that minus sign just to make it a little bit easier to work with. Minus 6 plus 8i. Okay, and we really don't need those. I don't know why I put those, but you don't need them. All right, so now when you get to this point and you've distributed, all you have to do is combine the real parts and the imaginary parts. So minus 2 minus 6 is going to be a minus 8. Minus 4i plus 8i is going to be a plus 4i. Boom. There it is. There it is. I was trying to say there it be and there it is. There it biz. 65, sorry. If you're looking at how to do these problems in the book, I don't want to mess you up. Okay. Here is where it gets really interesting. 6i minus 4i. Okay, when we multiply, same idea. We can just multiply. So minus 6 times a minus 4 is going to be a 24. I times I is going to be I squared. Ooh, what is I squared? Remember, this is the very definition of an imaginary number. If I is equal to the square root of minus 1, then I squared is equal to minus 1. Okay, this is kind of the important fact here. So if you get to something like this where you've got a higher power of I, you can substitute I squared for minus 1. So this is the same as 24 times minus 1, which is equal to a minus 24. Okay, so that's how you do that kind of problem. In fact, this actually shows up more often than you think. A lot of higher powers of I. We're only going to go up to squared in this class. If you go to college algebra, we'll talk about higher powers of I. Like you'll be able to find what the I to the 2,787 is. It's actually pretty easy to find that, but we're not covering it in this class, so you don't have to worry about it. No worries. Just a little preview for what's ahead. All right, so let's go ahead and look at question number 74. Okay. 3 plus 3i minus 2 plus 3i. Okay, so these, if you notice, each of these individual pieces in this, in this problem, they're actually both in standard form. This is actually the way that we need to write our solution. It needs to be similar to each of these individual pieces. Not together, but it needs to look like A plus BI. Okay, so that's the idea. So here, what we're going to do is we're going to FOIL just like we would a normal factor when multiplying out factors. So the first 3 times a minus 2 is going to be a minus 6. Outside, 3 times 3i is going to be 9i. Inside, 3i minus 2 is going to be a minus 6i. And then 3i times 3i is going to be plus 9i squared. Okay? Don't forget you need to multiply the 3's and multiply the i's. All right, so this is going to be a minus 6 plus 9 minus 6 is a plus 3i. And then I've got the funny looking 9i squared. Remember, I squared is equal to a minus 1, so we can make the substitution here. So minus 6 plus 3i. This becomes a plus 9 times minus 1, which is equal to minus 6 plus 3i minus 9. Okay? So notice what happens here. Minus 6 minus 9 is going to be a minus 15 plus 3i. Okay? And that right there is our solution. All right, let's do, I think I've got 3 more. I want to do another one of these, and then we'll jump into dividing. So 77, 2 minus 4i times 2 minus I. Okay, similar idea. FOIL this. So first, outside, 2 times minus I is minus 2i. Inside is minus 4i times 2, which is minus 8i. Last, minus 4i minus I. That's going to be a plus, because the minus signs are both positive. Make it positive. 4i squared. Okay? I can merge these two pieces together, so this is going to be a minus 10i. This is going to be plus 4i squared is a minus 1. So 4 minus 10i minus 4. And then this is going to equal, these cancel, as you can see, minus 10i is my solution. All right, so that's 77. Let's go ahead and continue moving forward. We're going to jump to question 102. Okay. 2 over 2 minus I. Now, the thing is, when we have to put it in standard form, we cannot have a denominator. Okay? You cannot have an I. I should rephrase. You cannot have an I in the denominator. Okay? So, this specifically is going to be where we introduce the idea of a complex conjugate. So remember when we did the conjugate with radicals, you are using the same first value, but you're changing the sign in between. So 2 minus I, we're going to multiply this in the denominator times 2 plus I. Both the numerator and denominator, this is all going to be multiplied, okay? Now, quick observation. This right here is just equal to 1. I'm just dividing something by itself, so it's fair game, I can do whatever I want, as long as I'm multiplying it by 1. This is a tricky or cool way of getting rid of the middle term in these problems. Okay, so the numerator is going to be 2 times 2 plus I. The denominator is going to be your first this is one of those special multiplication or factoring sorts of problems that we went through like a while back. But if you have the same thing and there's an opposite sign in between, you square both the first two and the last two multiplied together. So 2 times 2 is 4. I times I is going to be I squared, and then the middle is going to be a minus. So this is going to be minus I squared. Okay? That's one of those cool little tricks. So, we're not done. We're almost there. Remember, this is going to be a minus 1. So let's multiply this out. This is going to be 4 hang on. Yeah, 4 plus 2i. Hello. 4 minus a minus 1. Remember, we can substitute minus 1 for I squared. This is going to become 4 plus 2i all over 4 minus a minus 1 is 4 plus 1, which is 5. Okay? And so this becomes 4/5 plus 2 over 5i. Okay? All right, let's do one more problem. And then we'll call it quit skis. 112 minus 34 plus 31i all over minus 2 minus 5i. So this, again, similar idea. The same first term. We're just going to be replacing the sign in the middle. The terms are the same, we just replace them. So minus 2 plus 5i is going to be the thing that is the complex conjugate. Wow, I can't talk right now. 5i. Okay, so this is actually, these are each individually multiplying, okay? So I get minus 34 plus 31i times minus 2 plus 5i. That is a really fun factor to work on. I'm kidding, it's really not, but you know. 4, this is going to be 5 times 5 is 25 minus 25 times I squared. Okay? All right, so let's go ahead and do the numerator. I think I'm going to need some space here. So this is going to be minus 34. We're going to FOIL this like normal up top. Minus 34 times minus 2 is going to be a 68. First outside, so minus 34 times 5, that is going to be a minus 170 times I. Inside, 31i times minus 2 is going to be a minus 62 times I. And the last 31 times 5 is going to be 155. I times I is I squared. Okay. This is going to be 4 minus 25 times a minus 1, because I squared is minus 1. And then, let's see here. So, let's combine these two together. We can't merge that one because it's an I squared. However, I squared is a minus 1, so that makes life a little bit easier. Do I have space here? I don't know, I think I do. So this is going to be 68 minus 232i plus 155 times a minus 1 all over 4 minus 25 times minus 1 is going to be plus 25, so this is over 29. Okay, getting there. 68 minus 155 is minus 87. Okay, minus 232 times I all over 29. And surprisingly, 29 goes actually into both of these simultaneously. So this is going to be a minus 3. 232 divided by 29 is going to be a minus 8, and we have an I left over. Okay? So that is question 112. That is pretty much it. That's all we got for section 7.5. So complex numbers, real fun stuff. It's a little different, obviously, a way of looking at things, but yeah, the principles are pretty similar to the stuff that we've been doing up to this point. So if you have any questions, don't hesitate to reach out, let me know, and hope you have a great day.